Hello, chemistry students. So apparently in the chapter 5 notes for day 2, there was a missing part from Ernest Rutherford to just how small is an atom. So here is the missing part. So under Ernest Rutherford, he did that gold foil experiment. And because some of the alpha particles were deflected at large angles when they went through and actually came back at the source, he knew that there was a new theory needed for the structure of the atom. And because most of the alpha particles went straight through, he knew that the atom was mostly empty space. But because those alpha particles had a positive charge, he knew that all of the positive charge and almost all of the mass in the atom was concentrated in a small region. And that region has a big enough positive charge to deflect those alpha particles at large angles and also to deflect those alpha particles straight back. Rutherford called this the nuclear atom model. So really what Rutherford has discovered is he has discovered the nucleus of an atom. And he's discovered that Thomson's atomic model of this chocolate chip cookie or plum pudding is not correct. So what is the nucleus? It is the tiny central core of an atom. The nucleus is made of protons and neutrons. And what does this atom really kind of look like? The protons and neutrons are located in the positively charged nucleus. Now, again, why is that nucleus have a positive charge? Because inside of it are protons and neutrons. Protons have a positive charge, neutrons don't have any charge, so that gives the nucleus overall a positive charge. The electrons are distributed around the nucleus and occupy almost all the volume of the atom. Okay, so basically what we're saying here is that the nucleus is tiny in size compared to the size of the atom. Okay, so this is what Rutherford had discovered. Now, keep in mind, I talk about neutrons here, but neutrons actually haven't been discovered. So originally, right, they just thought the nucleus was made of protons. They're not going to know that there's neutrons in there until they discover neutrons exist within an atom. So the next scientist we're going to talk about is Henry Moseley. He lived from 1887 to 1915. And he's credited with this work in 1913. He was a British physicist. Now, remember that when Mendeleev put together the periodic table, he didn't like using atomic mass, and he actually thought that some of the atomic masses were wrong. And remember, he had also left some empty spots for undiscovered elements. Okay, so Moseley determined the atomic number of each known element. So he's going to figure out what the atomic number is of each known element. And he decides that that's actually a better way to put the periodic table in order. So he put the periodic table in order by atomic number instead of atomic mass. So again, Mendeleev had put it in order by atomic mass. He hadn't really liked that. He really didn't feel that was probably the best way, but it was the best information he had, because at the time that Mendeleev put together the periodic table, he didn't know that there were protons and electrons inside of atoms or neutrons. Okay, and so the best information he had was to use atomic mass. Moseley, now that they know about protons and electrons in atoms, he's going to use atomic number, which is the number of protons in an atom, okay? And he's going to put the periodic table in order by atomic number. And in fact, this is the way it is today. So this is still the way that the periodic table is organized to this day. Robert Millikan lived from 1868 to 1953. He's credited with this work in 1916, and he's a U.S. physicist. He was curious about the electron and knowing more about it. So Millikan was trying to figure out the quantity or size of an electron's charge. And he figured out that an electron is equal to 1 unit of negative charge. He also calculated an electron's mass. And he figured out that an electron, okay, had a mass that was equal to 1/1840th the mass of a hydrogen atom. So again, what he's saying here is if he has a hydrogen atom in one hand, it would take 1,840 electrons to equal the mass of just one hydrogen atom. And hydrogen is the smallest atom on the periodic table. So electrons are really, really tiny. To figure this out, he actually determined a ratio of charge to mass of the electron. Our last scientist that got skipped was James Chadwick. He lived from 1891 to 1974. He's credited with this work in 1932. And again, we haven't yet really talked about the neutron. James Chadwick confirmed the existence of another subatomic particle, the neutron. And again, he did this in 1932. So why would it take longer to discover that there's a neutron in an atom? Remember, a proton has a positive charge, an electron has a negative charge. A neutron doesn't have any charge at all. So this took longer because it was a lot harder to discover that there was yet another particle within this atom that didn't have a charge. So I think that that is the part of the notes that accidentally got skipped. I hope you have a nice evening.